on the swap instruction. Okay, again it comes as a part of the load and store instruction. So as the meaning states, swapping, nothing but moving the contents of the memory with the contents of a register. You can see the syntax here, it is SWB, and in the bracket there is B, meaning to say that there are two types for this. One is swapping a word, another one is a swapping a byte. See, either you can add a condition or not add a condition, it's optional. Okay, for example, EQ is a condition, or AL always, or NE not equal, or LO less than. So all those are conditions. Okay, and then RD comma RM comma RN, where RM and RN actually are source registers and RD is the destination registers as far as the syntax is concerned. But here we have given a bracket here, which means that Rn will always be a 32-bit memory address. Okay, let's again go detailedly here. SWP stands for swapping a word between a memory and a register. Okay, nothing but whatever is there in the register will be transferred to the memory. That is the meaning of that. It's only swapping a word here, and in this case it is byte. If you see that here, it's detailedly explained here. Memory 32 Rn, which means this is an address. Rn will be having a address. From that address, 32 bits or 4 bytes will be taken, and it will be assigned to a temporary location. Okay, a temporary location. Okay, and then RM, the contents of RM is nothing but the contents of a register that is actually stored in the 4 bytes of the memory location. And whatever the temporary location data, that means it consists of the 4 bytes. Now that is copied to the destination register, which means here there are two registers. Okay, one is the which held priorly, the register which holds the 32-bit value priorly, and now this is after the moment. That's why it's called as the destination. Okay, so we have swapped this value, we have moved this value, RM value, to Rn here, and the contents of Rn we have moved to RD here. So we have swapped the contents of memory location. Okay, usually this is called as an atomic operation. Okay, meaning to say that there are two operations which are going hand in hand. That is, you can see here it's right now divided into three, but actually here the movement of the data from Rn to RD and the data from RM to Rn. Okay, so it is going to happen simultaneously. So if there is an interrupt, okay, that interrupt cannot be addressed, because we say that the bus is held until the transaction is complete. Okay, now let's see an example. So we'll see here, before the execution, what we are going to do here, we are going to swap the contents of R2 with R1. Okay, so let's see, before execution, the 32-bit data which is in this particular address is 1 2 3 4 5 6 7 8. Okay, in this particular address. Okay, now this address is nothing but assigned to R2. Okay, and R0 is cleared. That is because our destination register, and R1 is nothing but our intended register, which we intend to swap the register, the word register, from the memory location. Okay, now you can see here, after swapping, what happens is the contents of R2 is going to reside in R0. You can see here it is 1 2 3 4 5 6 7 8, whereas R1 is not going to change. Okay, and whereas the R1's contents is going to be copied to the contents of R2. Okay, so you can see here R2 will be the address itself, 9000. Okay, and the memory you can see here, it's nothing but the contents of R1. I hope this is clear.